Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. This is part 11 video on the chapter of squares and square roots, where I will solve the first sample test paper 1, which consists of 12 MCQs, and ideally you should complete this test paper in 45 minutes. That is approximately 3 to 4 minutes per question. It is highly recommended that before solving this test paper, you should have already completed the studying your preparation on the chapter of squares and square roots and have solved quite a bit of problems from your test book or any other reference book. So this video is part of the playlist CBSE Maths for Class 8 following the test book of author R.S. Aggarwal. If you are new to my channel or not yet subscribed, and if you are watching my videos regularly and my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel, and also please do not forget to press the bell icon so that you will be notified by my future videos. So let's start solving the test paper 1. Okay, so I have the test paper on the left hand side. This is sample practice test paper 1. As I have said, I will prepare 2 test papers 1 and 2 for after completing every chapter. So this is test paper 1, which has 12 questions. All are MCQ. Each question has 4 choices A, B, C, D, and one of the choices will be correct. You have to select the correct choice. So you should try to solve this paper yourself first in 45 minutes or maximum an hour, and only if you are stuck at any problem, if you cannot solve it, then you can see this video as a reference for the solution, and while I will be solving the problem, you can pause the video and take a screenshot of the solution of the particular problem for your future reference. Okay, so let's start solving the problems. Problem number 1 says that it is given that a square root of some value is equal to 75. The value, then the value of, okay, so as you can see, it is given that square root of 5, 6 to 5 is given to be 75, and we are asked the value of square root of 0.5625 plus square root of 56.25. As you will notice that the given square root, the number inside is a natural number 5625, whereas the value that we have to find inside both the square roots, we are having the same number but in the decimal form. So the value for which we have to find the value, we can rewrite it as square root of now 0.5625. We can write it as 5625 divided by the number 0.5625 in the fraction form will be 5625 divided by 10 to the power 4, because the decimal places is 4, so we will have 10,000 and square root, plus we have square root of the given inside the square root, the number is 56.25. So in the fraction form, it will be 5625 divided by the decimal places is 2, so it will be divided by 100. Now this we can write it as per the the properties of a square root, that for positive numbers x and y, we know that for positive numbers x and y are positive numbers, we know that square root of x by y is equal to square root of x divided by square root of y. So we will apply this and we get the first term is square root of 5625 divided by the square root of 10,000, that is 4 zeros after 1, and the second term is square root of 5625 divided by square root of 100. Now this is, when we further simplify this, the square root of 5625 is already given to be 75. So we have 75, and the square root of 10 to the power 4. This is nothing but 10 to the power 4. This is 10 to the power 4, and this 100 is 10 to the power square. We know, you should have know this, that for x to the power, when x is a rational number, non-zero rational number, x to the power 2m, if you take the square root of x to the power 2m is always equal to x to the power m. If the power is a even integer, then x to the power 2m, any number, any non-zero rational number raised to the power an even power, its square root will be that number raised to the power the same power divided by 2. So we have now square root of 10 to the power 4 plus 75 and square root of 10 square. This is 75. Square root of 10 to the power 4 is 10 square, and square root of 10 square is 10. So this is equal to 75 divided by 100 plus 75 divided by 10. So this is equal to 0.75 plus 7.5. This is equal to 8.25 is the value answer. Okay, so the correct choice is C. The correct choice is C. Okay, so you can take a screenshot of the solution if you think it will be helpful to you. Let's do the next problem, problem number 2. It says that if x square equals to y, where x and y are natural numbers and y is a 2n plus 1 digit number, and y is a 2n plus 1 digit number, that is y is a number which has 2n plus 1 number of digits, then number of digits in x is. So it is given that x square is equal to y. This basically means that square root of y is x, and square root of y is x, and x and y are natural numbers. X and y are natural numbers, so definitely y is a perfect square number. Now it is given that y has the perfect square number, y is the perfect square number, has 2n plus 1 digit, Now then the number of digits in x is. Now one information is missing. N is it should be in the question in this question. Nothing is said about n. N should be a natural number. Now we know that for a perfect square, we know some property or information about the number of digits of a perfect square and the number of digits of the square root of that perfect square. So in this case, the perfect square number is y, its square root is x. So we know that x square, if we have x square is equal to y, this implies if y has n digits, if y has n digits, not this, if and x square is equals to y, that is y is a perfect square number and its square root is x. and if y has n digits, this will imply that x number of digits in the square root, x number of digits in the square root in x will be equal to n by 2 if n is even, and it will be n plus 1 by 2 if n is odd. So in this problem it is given that the number of digits in y is 2n plus 1. So for any natural number, n, 2n plus 1 is always odd, because for any natural number 2n will be an even number, and any even number plus 1 is always an odd number, so odd integer or odd natural number. So 2n plus 1 will always be an odd natural number. So this implies x will have 2n plus 1 by 2 digits. Since it is given that y has 2n plus 1 digits, and we know that 2n plus 1 will always be odd because n is a natural number. Any natural number multiplied by 2 is always an even number, and any even number plus 1 is always an odd number. So 2n plus 1 is odd, hence the number of digits in the square root of y, that is x, will be 2n plus 1, whatever the digits is there in y, that plus 1 divided by 2. So 2n plus 1 by 2. So this is 2n plus 2 by 2. This is equal to, if you take 2 common, 2n plus 1 by 2. This is equal to n plus 1. So x will have n plus 1 digits. So the answer is choice D. Okay, let's do problem number 3. Problem number 3. If there are 20 natural numbers between 10 square and x, then the value of root x is. If there are 20 natural numbers between 10 square and x, and then the value of root x is. So we know that, so we can see it is saying that it is given that 20 natural numbers, we know the property, a property from squares, that there are n square, there are twice n natural numbers between two consecutive squares, between n square and n plus 1 square. So we know this fact that there are 2n natural numbers between n square and n plus 1 square, where n is a natural number. So definitely if n is a natural number, n and n plus 1 will be consecutive natural numbers. Hence n square and n square plus 1 are also consecutive squares. So if you try to map, or if you see the problem, it is given that there are 20 natural numbers between 10 square and x. So if you can see that 20 is equal to 2 multiplied by 10, and at 2 into 10 natural numbers, it is given 2 into 10 natural numbers between 10 square and x. So you can see we have 10 here and we have 10 here. So definitely, if you the given information, if you try to relate the given problem statement with the fact that there are two n natural numbers between n square and n plus 1 square, you can say this implies that x will be equal to 10 plus 1 whole square, which is equal to 11 square. It is given that there are 20 natural numbers between 10 square and x, and we know that there are 2n natural numbers between n square and n plus 1 square. If you try to correlate the given information in the problem statement and the property of square numbers, then you can easily find out that for the given problem, x has to be the next square number after 10 square, and the next perfect square after 10 square is 11 square. So definitely x has to be 11 square. So this implies x is 11 square. So this implies root x will be equal to root of 11 square, which is nothing but 11. So the answer is choice C. Okay, let's do problem number 4. Problem number 4. Find the value of x if, so an equation is given on the left hand side is having nested square roots. So we are having a square root of 274 plus again square root of x plus again square root of 169 is equal to 17. Now this is a common pattern of questions which the one way of solving it, the way I will solve is that whether it's on the left hand side or on the right hand side, if you see a square root, inside square root, if you see a single constant number, for example in this we are having square root of 169. If that number is a perfect square, then you can easily find its square root. If it's a if you can figure it out that it's a perfect square number, then find its root. We know that root 169, this is a very standard square root. Square root of 169 is 13. So we can say that this implies square root of 274 plus square root of x plus 13 is equal to 17. Now how can we get x from here? You can see that the left hand side is a square root and the right hand side is a constant number. What you do is you take squaring both sides. That is, you take the square of both the left hand side and the right hand side, and the equality will remain same. Squaring both sides, meaning if you have for any constant numbers a and b, if you have a equals to b, you can always say that a square is equal to b square. A square is equal to b square. You can always say that. So squaring both sides, we get 274 plus square root of x plus 13 square is equal to 17 square, and 17 square is equal to 289. Now the left hand side, we know that square of a square root of a number, if you take the square of a square root of a number, is equal to that number itself. That is, I am squaring the square root of x. This will be equal to x. So this implies we have 274 plus square root of x plus 13 is equal to 289. Now this will imply, I will bring all the constant to the right hand side, and we get square root of x plus 13 is equal to 289 minus 274. This is equal to 15. This is equal to 15. Now I will take square again on both sides. Squaring both sides. Squaring both sides, we get square root of x plus 13 and whole square, its square is equal to 15 square, which is equal to 225. This implies again the square root of x plus 13 is obviously x plus 13 is equal to 225. This implies x is equal to 225 minus 13. This is equal to 2, 1 and 2, 212. So the correct choice is D. The correct choice is D. Okay. Let's solve problem number 5. Problem number 5, it says that let n be a two-digit number with a being the digit at tens place and 3 the digit at units place. If n square equals to x a square plus y a plus z, then the value of square root of x plus y plus z. So it is given that the number n is of the form, it is a two-digit number where a being the digit at the tens place, so a is the digit at the tens place, and 3 is at the digit, 3 is the digit at the units place. If n square, it is given that n square is equal to x a square plus y a plus z, then the value of, okay. So now we know that if n is a two-digit number of the form a3, where 3 is the digit at the units place and a is the digit at the tens place, we know that n can be, in the expanded form, n can be written as 10 multiplied by a plus 3, that is 10 a plus 3. Now it is given that n square, what will be n square? N square is equal to 10a plus 3 square, and we got the form a plus b whole square, and we know that a plus b whole square, where a and b are some constant numbers, a plus b whole square is, we know the formula, a square plus 2ab plus b square. So over here we have 10a plus 3 whole square, so this will be 10a square plus 2 into 10a multiplied by 3, and we have 3 square. So this is equal to 10a square means 10 square multiplied by a square, and we have 2 into 10a into 3 is 60a, plus we have 9. So this is equal to 100, 10 square is 100, 100a square plus 60a plus 9. Now it is given that this, we have found this. Now it is, the problem says that n square is equal to x a square plus y a plus z. So this implies, if you compare our result, our n square and the given n square, if you compare, you will see, if you bring the left right hand side, so this implies, we can say that the value of our n square is 10, 100 a square plus 60a plus 9. This should be equal to the given value of n square, that is xa square plus ya plus z. Now, if I bring all the terms on the left hand side, we get 100, and we get 100a square, and we group the terms, the similar terms, like the coefficient, the terms containing a square, the terms containing a, and the constant terms. We will have 100a square minus x a square. We will have 60a minus ya and plus 9 minus z equals to 0. So this implies that from the first term, if you take a square common, we get 100 minus x a square plus, from the second term, if we take a common, we get 60 minus y a, and we have 9 minus z equals to 0. Now, so we can see the right hand side is 0 and the left hand side is an algebraic expression having three terms, where the first term is containing a square, second term is a, and the third term is a constant. Now, from this, we always say, if you have something like this, that place. Okay. Now remember that a is a digit. So it will be anything from 1 to 9. So 1 to 9. Now, so if you have this kind of equation where we have, so this will imply that all the terms, the left hand side, the terms will be equal to 0. That is, we will have now. It was not necessary to I will ignore this part. Let's not do this thing. Ignore this part. So from here, from this equation, let's say this equation where we have 100a square plus 60a plus 9 equals to xa square plus ya plus z, we can comparing the coefficients of a square, a, and the constant term on both sides. We can say from equation 1, comparing coefficient of a square, we get the coefficient of both the sides. The coefficient of a square on both the sides has to be same, because we are having equality. So 100a square plus 60a plus 9 is equal to xa square plus ya plus z. So this means that the coefficient of a square, a, and the constant term on both the sides should be equal. So we get, if we compare the coefficient of a square, we get x equal to 100. Similarly, we will get if we compare the coefficient of a, we will get y is equal to 60. And if we compare the constant term on both the side, on the left hand side the constant term is 9, and on the right hand side the constant term is z. So we will have z equals to 9. So this implies that x plus y plus z is equal to 100 plus 60 plus 9. This is equal to 169. This is equal to 13 square. 13 square. So therefore, square root of x plus y plus z is equal to 13. So the answer is choice D. Answer is choice D. Okay, let's do question number 6. Question number 6 says, if the value of square root is given, square root of 0.2209 in standard form is x to the power x multiplied by 10 to the power m, then the value of x plus m is. Okay, so it is given that square root of 0.2209 is in standard form x to the x multiplied by 10 to the power m. So we know the number in the standard form is x multiplied by 10 to the power m, where x has to be greater than equals to 1 and less than 10, and m is non-zero integer. It can be positive or it can be negative. It is an integer not equal to 0. We know this. So we have to find x and m where it is the standard form, where x multiplied by 10 to the power m is the standard form of the square root of 0.2209. So we can easily find the square root of 0.229 using the long division method. So we mark the periods from the right hand side, and the periods are 0, 9, 2, 2 and 0. So the first divisor obviously will be 0. So 0, 0, 0, remainder is 0. We bring down the next period, that is 2, 2, and at this stage all the digits before the decimal point was exhausted. So we have to put a decimal point in the question. So we brought down the next period 2, 2 and appended it with the remainder 0. So the next dividend becomes 22. Now we multiply the next divisor. Partial divisor will be the 2 multiplied by the current question. The current question is 0. 2 multiplied by the current question ignoring the decimal point. So the current question is 0 point. It means 0. So 0 multiplied by 2 is 0. So 0. So now we have to consider the digit x such that 0, the 2-digit number 0x, which is essentially x, 0 multiplied by x should be less than equal to 22. So this implies that x will obviously be equal to, it cannot be 5 because 5 into 5 is 25. So x is equal to 4. So x will be equal to 4. We have 4 will be appended to the current question. 4 and 4 multiplied by 4 is 16. We subtract 16 from the current dividend, and we have the remainder as 6. Now we bring down the next period, append it with the remainder, and the next dividend becomes 609. Now the next divisor, partial divisor, will be the current question ignoring multiplied by 2 ignoring its decimal point. The current question is 0.4. If we ignore the decimal point, it is 4. So 4 multiplied by 2 is 8. Again we have to find the digit x such that the 2-digit number 8x multiplied by x is less than equal to 609, and x has to be the greatest x. So whenever we are find in a long division method, always remember that when we find the digit x in the divisor, so that x has to be the largest x. Now what can be the largest x such that the 2-digit number 8x multiplied by x is less than equal to 609? Can it be? It cannot be 8. Can it be 7? Can it be 7? 87 multiplied by 7, let's see, 49 and 56, it is exactly matching. So x is equal to 7. So x will be 7, x will be 7, and 7 will be appended to the current question, and 87 multiplied by 7 is 609. We are having 0 remainder and there are no more periods left. So we have square root of 0.22009 is equal to 0.47. Now we have to convert this into a standard form. So in the standard form, we know that x will be greater than equals to 1 and less than 10. So we can write 0.47 as 4.7 multiplied by 10 to the power minus 1. So we multiply with 0.47 so that it becomes greater than equals to 4 and less than 10. And since we multiplied it by 10, we have to multiply. We have to also divide it by 10. So the 1 by 10 is 10 to the power minus 1. So we have this. So this is the standard form, is in standard form. So we can clearly say that x is equal to 4.7 and m is equal to minus 1. So this will imply x plus m is equal to 4.7 minus 1, which is equal to 3.7. This is the answer. So the correct choice is C. Okay, let's do problem number 7. Problem number 7 says, let P and Q are the least number to be added and subtracted from 1500 to make it a perfect square respectively. Okay, so P is the least number to be added to 1500 to make it a perfect square, and Q is the least number to be subtracted from 1500 to make it a perfect square. Then the value of P minus Q is, we know that we have solved problems where we have to find the least number to be added or subtracted from a given number to make it a perfect square. So the given number is 1500, and the initial step, the obvious step, is to find the square root. We have to find the square root of the given number. Let's use the long division method. So we mark the periods from the right hand side, 0, 0 and 15. We start the long division method starting from the leftmost period, that is 15. So obviously the divisor will be 3. 3 into 3 is 9. The remainder is 6. We bring down the next period, 0, 0. The dividend becomes 600 and the next divisor, partial divisor, will be 6. 3 into 2. Current quotient is 3 multiplied. Current quotient multiplied by 2 is 6. Now we have to find the digit x after 6 such that the 2-digit number 6x multiplied by x should be less than equal to 600 and x should be the maximum value. The maximum value of x such that the 2-digit number 6x multiplied by x has to be less than equals to 600. So this implies, what can x be? Can x be 8? Can x be 9? Can x be 9? I don't think so. Can x be 9? 69 multiplied by 9 is 9981 and 54 62. No, it is exceeding. Can x be 8? 64 and 48 and 54. 64, 48, 54. Yes, this can be. So x is equal to 8. X is equal to 8. So we write 8 over here. We append 8 to the quotient, and 68 multiplied by 8 is 544. 544, and we are having a remainder of 56. We are having a remainder of 56. Okay. Now, how do we find from here? How do we find the least number that must be subtracted from 1500 to make it a perfect square? So P, which is given as Q in the question, it is given in the question problem. It is given that P and Q are the least number to be added and subtracted from 1500 to make it a perfect square. So Q is the least number to be subtracted from 1500 to make it a perfect square, and we know that in a long division method for finding the square root, if there is a remainder, that remainder is the least number that we must subtract from the given number to make it a perfect square. So this implies that Q is definitely 56. And what about P? P is the least number that must be added to the given number to make it a perfect square. We also know that 38 square is 38 square is less than the given number, and also the given number is less than 39 square. 39 square. So the number that must, the least number that must be added to 1500 must be the next immediate next perfect square, which is greater than 1500. So this implies that that number, the least number when added, that is Q, that is P, when added to 1500 should give 39 square. That is 1500. If we add, if P is the least number to be added to 1500 to make it a perfect square, then we must have 1500 plus P is equal to 39 square. So this implies P is equal to 39 square minus 1500. This is equal to, now 39 square is now okay 81 and 35 27 11 1521. Now you must be very prompt in finding the square of two-digit numbers using any methods. So we have studied the column method for finding the square of two-digit number, or even diagonal method, or even the whole square method. That is 39 square is equal to 30 plus 9 whole square. 30 plus 9 whole square, this is a plus b whole square form. It will be 30 square plus 2 into 30 plus into 90, and we have 9 square. This is equal to 900 plus 2 into 6, 30 multiplied by 9 is 540, and we have 81. So this will be 900, 540 plus 81. This is 1, 12 and 15. 1521. So this is 1521 minus 1500. This is equal to 21. So P is equal to 21 and Q is equal to 56. So we are asked to find the value of P minus Q. So this implies P minus Q is equal to 21 minus 56. This is equal to minus 35. Minus 35. So the correct choice is A. Okay, let's do problem number 8. It says let y be a positive integer. Let y be a positive integer. Okay. Long division method of finding the value of square root of y gives a quotient of x and a remainder of z. Then which of the following is correct? Y is a positive integer, so we are doing some long division method. over here, and we are doing some long division method, and finally we got a remainder of z, and the question is x. So we are y is a positive integer, and we are finding the square root of y using long division method, where the final quotient is given to be x. The final quotient is given to be x, and the remainder is z. Then which of the following is correct? Now you must know very clearly the concept that if you have, when you are doing a long division method to find the square root of a number y, and the final quotient is x and the final remainder is z, this implies that x square plus z is equal to y. You are finding the just like as a side note, if you are doing a long division, normal simple division, let's say with the divisor is, let's say p, and if you are dividing x, and let's say the quotient is q and the remainder is r, this implies that x, the number x is nothing but p q plus r. Similarly, for a long division method in finding the square root of a number, if the current quotient, if the given number whose square root we are finding is y, the quotient, the final quotient is x, and the remainder is z, then we will have the relation that this means that x square plus z is equal to y. So now we have to see which choice is it matching. So the choice is, this is a very conceptual question. The choice is C. Okay. Let's do problem number 9. For odd positive integer m, if p be the least number to be multiplied with the number n equals to 2 to the power m multiplied by 5 to the power twice m and multiplied by 3 to the power 2m plus 1, to make n a perfect square, then the value of, okay, what is given, m is a odd positive integer. So little details you have to keep in mind. So m is a positive odd integer, and p is the least number to be multiplied with the number. So what is the number given? N equals to 2 to the power m multiplied by 5 to the power twice m multiplied by 3 to the power twice m plus 1. So this is n. So it has given n in the form of prime factors. So we are having prime factors of 2, 5 and 3, and we are having multiple factors of 2, multiple factors of 5 and multiple factors of 3 as their power. So power of, so we have m number of factors 2, 2m number of factors 5, and 2m plus 1 number of factors prime factor 3. Now it is saying that if p be the least number to be multiplied with the number to make it a perfect square, then the value of, okay. So we know that when we do, we have solved a kind of problem that given a number, we have to find what is the least number we have to multiply a given number so that it becomes a perfect square. So what do? We first take the prime factorization of the given number, and we see and we create the pairs of equal factors, and whatever factors in the prime factorization of the given number is left alone, that is, it is not part of any pair, then those numbers, product of those factors, is actually the least number by which the given number can be multiplied or divided to make it a perfect square. So in this case, the given number is n. The given number is n, and we can see its prime factorization is, the given number is already given in the form of prime factorization. Now this is equal to 2 to the power m multiplied by 5 to the power m. This I can write 5 to the power 2m as 5 to the power m square, and this is 3 to the power 2m plus 1. I can write it as 3 to the power 2m multiplied by 3. Now we have to see in this prime factorization which are the factors which are not part of any pair. So 2 to the power m is a positive odd integer. If m is a positive odd integer, now you can see that m is a odd integer. If m is an odd integer, this will imply that this will imply that uh, 2m 2 to the power m uh, will need to be 2 to the power m is not forming pairs of factor 2. Factor 2. Since m is odd, so if m is odd, we cannot. So 2 to the power m means 2 multiplied by 2 multiplied by 2m times is equal to 2 multiplied by 2 multiplied by 2 m times. And if you try to create pairs from the factors of 2 to the power m, we will see that we cannot create we can create pairs, but 1 2 will be left behind. Where 1 2 will be left behind, it will not be a part of a pair. So if m is odd integer, 2 to the power m is not forming pairs of factors 2. That is, we'll have 2 as not part of any pair. Also, since m is a odd integer, 5 to the power m and its whole square will always form pairs of equal factor of 5. 5 to the power 2m means 5 to the power 2m means 5 to the power 2m means this is equal to 5 multiplied by 5 multiplied by 5 multiplied by 5, this way up to 2m times, and 2m is an even integer. Whether for any integer m, twice m will always be an even integer. So we can always have pairs of equal factors of 5 in 5 to the power 2m. So this is okay. Now similarly 3 to the power 2m will be equal to 3 multiplied by 3 will form pairs of equal factors of 3. We have 2m times 3 to the power 2m means 3 multiplied by 3 multiplied by 3, like this. 3 multiplied by 3 2m times. So definitely 3 to the power 2m is also having equal pairs of equal factors, that is equal factors of 3. So no factor in 3 to the power 2m is left alone. Every factor is a part of a pair. So don't, and we see that the 3 is left behind. So 3 is left behind. So we can say that this number to be multiplied with n to make it a perfect square perfect square is 2 multiplied by 3, because in this factorization of the given number n, we can see that all the factors of 5 can be paired, are part of some pairs, uh, and and this 3 to the power 2m also, all the factors of 3 are part of some pair, they can be paired. The only problem is 2 to the power m and the 3. 2 to the power m, since m is an odd positive integer, the 2 to the power m will not make pairs of equal factors of 2. So 1, 2 need to be multiplied to make it so that 2 to the power 2 raised to the power m plus 1. So if we multiply 2 to the power m is odd positive integer. So if I multiply 2 to the power m, if I multiply with another 2, this is becomes 2 to the power m plus 1, where m plus 1 is even as m is odd. M is given to be odd, so m plus 1 will be even. So if m plus 1 is even, then 2 to the power m plus 1 can be all the factors of 2 will be part of some pair. So we can see that the least number to be multiplied with this number n is 2 into 3, that is 6. Okay. Now the question is, which is given to be p? Which is given to be p? In the problem, it is said that if p be the least number to be multiplied with the number n to make n a perfect square. So we have already found that the least number to be multiplied with this n given number is 6. So we can say that p is equal to 2 multiplied by 3 is equal to 6. Now it is asking the value of square root of n divided by p. Now what will be the square root of n? Oh, define. Okay. Now I think there is a problem there is a little issue in the problem. Actually, it is asking the value of square root of n divided by p. Actually, it should be square root of the number n. Actually, this should be np. It is asking n is, we can see, is not a perfect square. Since it is lacking, it need to be multiplied or divided by 6 to make it a perfect square. So n is not a perfect square. So it is not a perfect square. So I think the problem should be to find the value of square root of n p and then divided by p. Np, because when we multiply p with the number n, then it becomes a perfect square. Then we can find the square root. So let's see if this is what whose value we need to find. What will be? Now what will np be? Np will be equal to 2 to the power m. We have p means p, we know that 2 multiplied by 3, p will be 2 multiplied by 3, which is 6. So if we multiply n with p, we have 2, we have n as 2 to the power m, 5 to the power 2 twice m, and we have 3 to the power 2m plus 1. This was the initial given prime factorization of n. Okay, this we multiply with np, which is 2 into 3. Now if you merge the factors 2 together, we get 2 to the power m multiplied by 2 is 2 to the power m plus 1, and 5 remains, 5 to the power twice m, and 3 to the power 2m plus 1 multiplied by 3 is 3 to the power 2m plus 2. So this is equal to 2 m plus 1 multiplied by 5 to the power 2m and 3 to the power 2 into m plus 1. Now, so this implies square root of np will be equal to square root of 2 m plus 1 multiplied by 5 to the power twice m multiplied by 3 to the power twice m plus 1. Now, one note, one concept that I already discussed in the theoretical videos regarding finding the square root of numbers or properties of square roots is that if you have a number in the form of factors, powers of factors, that is products of exponents, let's say x to the power 2m multiplied by y to the power 2n multiplied by z to the power 2 p, then square root of its square root will be equal to the powers will get the powers of all the powers will get divided by 2. So this will be x to the power m, y to the power n, z to the power p. So the square root of x to the power twice m y into multiplied by y to the power twice n multiplied by z to the power twice p will be equal to x to the power m multiplied by y to the power n and z to the power p. This is a very standard result you should understand or remember. Okay, so now if we apply this concept, we will get the square root as 2 to the power, all the powers will get divided by 2 multiplied by 5 to the power 2m divided by 2 is m and 3 to the power m plus 1. So this implies that square root of n into p divided by p is equal to 2 to the power m plus 1 by 2 multiplied by 5 to the power m multiplied by 3 to the power m plus 1 whole divided by p, where p is, we know p is 6. So the answer is choice D. The answer is choice D. So it's there is a little problem error in the problem. It should be the value of square root of n p, n multiplied by p and then divided by p. Okay, let's do problem number 10. If p and q are odd and even integers, let me quickly check if everything is visible or not. Okay. If p and q are odd and even integers respectively, then the number p square plus q square plus pq is even, odd, either a or b cannot be said. Okay. If p and q are odd and even integers, now p is even, we know from the properties of square of a number that properties of squares implies, we know that p is even, that p square, that is its square, p square is also is even. Similarly, if p and q are odd and even integers, sorry, in the problem p is given to be odd. So if p is odd, we know that square of an even number is even and square of an odd number is also odd. So therefore, if p is odd, p square will also be odd integer. Okay. So q is even, given q is even implies q square is even. Now what about pq? Pq will be is, so these two, that p is odd, p, I'm sorry for my weird way of solution. If it is given that p is an odd integer and q is an even integer, this will imply that the product of a odd integer and an even integer is always even. The product of an even integer and an odd integer is always even. So pq is even. So we see that the number, this will imply that p square plus q square plus pq is what will be this number? Will it be even or odd? P square is odd, q square is even. Now odd plus even is always odd plus even is always odd. Odd plus even is always odd. So we can say that this is equal to p square is odd, q square is even, and pq is even. Now we have to decide whether the sum of an odd integer and plus the sum of an even integer plus the sum of an even integer, the whole sum is an even or odd. Now even plus even is odd. This even plus even any even number plus sum of two even numbers is always even integer. Sum of two even integers is always an even integer, and odd. So odd plus even implies odd. Sum of an odd integer and an even integer is always odd. So this implies that p square plus q square plus pq is odd, will be odd, because p is an odd integer, therefore p square will be odd. Q is an even integer, so q square will be even integer, and pq, that is a product of an odd integer and an even integer, is always an even integer. So we have the sum of odd, even, and even. Sum of two evens is always even integer, and sum of an odd and an even integer is always an odd integer. So finally the result p square plus q square plus pq is an odd integer. So the answer is choice B. Let's do problem number 11. Let x and y, where x is less than y, are two consecutive positive integers such that x plus y is equal to 13 square. Then the value of okay. Now it is given that 13 square x and 13 square is equal to x plus y, and it is given that x and y are consecutive integers. X and y are consecutive integers and x is less than y. So x is the smaller consecutive integer and the y is the next larger consecutive integer. That is the next integer, consecutive integer to x is y. Now we know that there is a concept we have learned that the square of a two digit, the square of I'm not sure whether two digit or any number of digits, the square of odd integer, the square of odd integer can be expressed as the sum of two consecutive integers. So if m, we know that we have a concept for odd integer, m, that is odd positive integer m, m square can be expressed as m square minus 1 by 2 plus m square plus 1 by 2, and you will see that m square minus 1 by 2 and m square plus 1 by 2 are consecutive integers. This is a concept I have discussed in some video. If you can check my videos in the same playlist, CBSE 8 RS Aggarwal, on the chapters of squares and square roots. So for example, if you take 11 square is equal to 121. 11 square is equal to 121, and 11 square minus 1 by 2 is 121 minus 1 by 2, that is 120 by 2, 120 by 2, that is 60. Also 11 square plus 1 by 2 will be equal to 121 plus 1 by 2, which is 122 by 2. This is equal to 61. So 60 and 61 are two consecutive integers whose sum is equal to 121, and 121 is equal to 11 square, and we got 60 and 61 from 11 only. So 60 was 11 square minus 1 by 2, and 61 was 11 square plus 1 by 2. So this is the concept that we have to apply to solve this problem. When it is given that x and y are two consecutive integers, but x is smaller than y, which is equal to 13 square, and 13 is a odd integer. So we must have x will be equal to 13 square 13 square minus 1 by 2, and y will be equal to x plus 1 definitely, but its formula is 13 square plus 1 by 2. So this implies x is equal to, if you find x, then no need to find y as 13 square plus 1 by 2, because y will anyway be x plus 1, because x and y are consecutive integers. So what is x? So x is 13 square is 169 minus 1 by 2. This is 168 by 2. This is 84. X is 84. This implies y is 84 plus 1, since x and y are consecutive integers, that is 85. So we found x and y. Now we have to see what is root over square root of x plus 16. Put the value of x, square root of 84 plus 16. This is equal to square root of 100. This is equal to 10. So square root of x plus 16 is 10. And what is square root of y plus 36? So put the value of y is 85. 85 plus 36. This is square root of 121. This is 11. This implies square root of x plus 16 minus square root of y plus 36 is equal to 10 minus 11. This is minus 1. This is minus 1. So the correct choice is C. C is the correct choice. Can you see the questions? Okay. Let's do the last problem, that is problem number 12. Two positive numbers are in the ratio 1:3. If sum of their squares is 90, the larger number is. Okay. So if the sum of the squares is 90, so this is a very typical problem of ratio and proportion. We usually solve this problem by assuming that since the ratio of two numbers is given, let the numbers be, we assume the numbers in terms of the given ratio. So let the numbers be 3x and x and 3x. Since the ratio is 1:3, the numbers we assume will be x and 3x. This implies it is given that the sum of the squares is 90. This means x square, the square of the first number is x square, and the square of the second number is 3x square is equal to 90. So this implies x square plus 9x square is equal to 90. This implies 10x square is equal to 90. This implies x square is equal to 90 by 10, which is 9. This implies that x will be equal to square root of 9, that is 3. So x is 3. Now what is it is asking the larger number is. This implies the larger number is 3x. 3x is equal to 3 multiplied by 3, that is 9. So 9 is the larger number, and the correct choice is C. So this brings to an end in solving the sample test paper 1. I hope this set of problems will give you a good evaluation of your understanding on the chapters of squares and square roots. Uh, uh, I will prepare another test paper, that is test paper number 2, that I will prepare and solve tomorrow. So please stay tuned for the tomorrow's video on sample test paper 2. And then also please look out my other playlist, that is CBSE 8 Hot, where I come up with 10 good problems for every chapter every now and then. Those problems will be also a good set of problems, harder problems, and they are tagged as HOT. HOT means high order thinking problem. So I hope this video was beneficial, and this set of problems will give you a good practice to check your understanding and coverage of all the concepts of squares chapter, concepts of the chapter squares and square roots. So if this video was beneficial, then please like it, share it with your friends, and also please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. So thanks for watching, and until the next video, take care and bye.